Okay, so let's begin our discussion of projectile motion. So we're looking at C03 projectile motion, the problems 1 and 2 to start off with. Okay, so number 1 says a 10.0 gram marble is rolled down a ramp and off a table with a horizontal velocity of 1.2 meters per second. The marble falls into a cup placed 0.55 meters from the table's edge. How high is the table? So right off the bat, they gave us one piece of junk information, the 10 gram marble. Okay, so we don't care how much the marble weighs. Okay, the reason that we don't care what the mass of the marble is, rather than the weight. So 10.0 grams. We know that without air resistance, the mass of an object doesn't matter when we're talking about velocity and acceleration. We know that everything falls at the same rate. So it was given an initial horizontal velocity, or it was given a horizontal velocity of 1.2 meters per second. We don't care that it's 10 grams, doesn't mean anything to us. All we care is that the horizontal velocity was 1.2 meters per second, which means from where it rolled off of the table. So here's my awesomely drawn table right here. Okay, the marble rolls down a ramp, okay, and then off of a table and lands 0.55 meters away from the table. So 0.55 meters away from the table and has a horizontal velocity of 1.2 meters per second. So in order to figure out the height of the table, first we need to know how much time does it spend in the air. And so that's why it gave us the velocity and the distance from the table's edge. Because we know that velocity is equal to distance divided by time. Okay, so velocity is equal to distance divided by time. So our velocity in the x direction is equal to the distance in the x direction over the time. Notice that the time doesn't have an x direction and a y direction because the time is just the total time that it spends going from the table to the ground. So we are looking for dy. We're looking for the distance in the y direction, but before we do that, we have to figure out how much time does it spend in the air. So we plug in the values that were given. 1.2 meters per second is equal to our distance in the x direction over time. Okay, so our distance in the x direction was the 0.55 meters. So I'll go ahead and plug that in. So 0.55 divided by time. So if I rearrange the equation, I'm going to get time is equal to 0.55 divided by 1.2. Okay, so in other words, I multiplied both sides by time, and then I divided both sides by 1.2 in order to rearrange that, so I get t equals. So t equals 0.55, and that's 0.55 meters divided by 1.2 meters per second. So the meters are going to cancel out, seconds is going to move to the top, so we're left with our time, which is what we want. And when I do that calculation on the calculator, 0.55 divided by 1.2 gives us a time of 0.458 seconds. Okay, I'm just going to go ahead and leave it at about that. My significant figure should actually be two significant figures, but I have more calculations that I need to do, so I'm going to go ahead and leave that so that I can eliminate error as much as possible from my solution. Now that I know the time that it spends in the air, now I can just use my standard equation to figure out how far something has fallen based on the time that it spends in the air. So the distance in the y direction is equal to the initial velocity in the y direction, Okay, so the initial velocity in the y direction times time plus 1/2 AT squared. Okay, so I've got my initial velocity in the y direction. Well, if it rolled off the table with a horizontal velocity of 1.2 meters per second, it doesn't matter that it had a horizontal velocity. When it rolls off the table, it immediately starts falling. Okay, its initial vertical velocity is actually 0. So 0 times time, no matter what the time was, in this case it was 0.458 seconds, but it doesn't matter because our initial velocity was 0, so that means this term goes away. Okay, so all we're left with is dy is equal to 1/2 AT squared. So I'm going to go ahead and plug in what I know. So 1/2 times A, well, our acceleration due to gravity is 9.8 meters per second squared. Okay. Times our time squared, well, our time was 0.458 seconds squared. Okay, so when I do 0.458 squared and s squared, or seconds squared, we know that that's going to wind up canceling our seconds out. So we're going to be left with meters, which is what we want. So now we just need to get our calculator and go ahead and perform the calculations. So I'm going to start, of course, with order of operations. I'm going to start by squaring my 0.458. So 0.458 squared is equal to 0.209764. This will get rounded later, times 9.8 times 1/2. So times 9.8 times 1/2 is equal to 1.0278, and then there's a couple more digits beyond that. But going back to my original, we only have two significant figures here for the distance, two significant figures here for the velocity, which means that my final answer must have two significant figures. Well, there are my two significant figures right there. So if I round, the 2 does not round the 0 up. So that means that my final answer is that the table is 1.0 meters tall. Okay, so now we're going to go ahead and take a look at problem 2. It says a projectile is fired horizontally from the roof of a building 32 meters high at an initial velocity of 25 meters per second. Find A, the total time the projectile is in the air. Okay, so A, we're going to be looking for time. That's what we're looking for. And B, where the projectile hits the ground. So what is the horizontal distance away from the building? So that's going to be our distance in the x direction. Okay, so we're basically working our way backwards from the previous problem. We're first going to figure out the time, and then we're going to figure out the horizontal distance. Well, we were given a velocity and a vertical height of the building. So again, we have a building. We have the building is 32 meters tall, 32.0 meters tall. Okay. 2.0 meters tall. Okay. The projectile comes off of the building with an initial velocity. That's important. An initial velocity of 25 meters per second. And of course that's in the x direction, so that's our initial velocity in the x direction. So initial velocity in the x direction is equal to 25.0 meters per second. We want to figure out how much time it spends in the air for A and what is the distance away from the building that it hits the ground. So for A, again, we're going to use our vertical distance formula because we were given an initial velocity. We want to find time. We know that the acceleration due to gravity is 9.8 meters per second squared. So if I plug everything in, or if let's first set this up, dy is equal to the initial velocity times time plus 1/2 AT squared. Okay, so we're going to plug in everything that we know, and then we are going to go from there. Okay, so our distance in the y direction is 32 meters. Our initial velocity is 25. Actually, no, we're going in the y direction. I made a mistake here. So we're going in the y direction, so all we care about is our initial y velocity, not our x velocity. Our initial y velocity is 0. Okay? Because when we fire it off of the building, if we're firing it horizontally, then that means that its initial vertical velocity is 0. So again, just like the last one, that's going to cancel out, and we're just left with 1/2 times 9.8 meters per second squared times time squared. Okay, and that right there is a common mistake. Okay, we look and we say, oh, initial velocity, and it said initial velocity in the problem. What it's telling us though is that is the initial horizontal velocity, not the initial vertical velocity. Okay, if it's fired horizontally, the initial vertical velocity is actually 0. Because it has no, we're not firing it down, we're not firing it up, okay, we're firing it horizontally, which means that its initial vertical velocity is 0. So we have, that cancels out, so we're left with 0 plus 1/2 times 9.8 meters per second squared times time squared. So what we need to do is first half of 9.8 meters per second squared is 4.9 meters per second squared times t squared is equal to 32.0. So I'm going to go ahead and get my calculator out, and I'm going to divide both sides by 4.9. Okay, so 32 divided by 4.9 is equal to about 6.53, which is equal to t squared. And then the last thing that I need to do to solve for t is to take the square root of both sides. So the square root of 6.53 is approximately 2.56 seconds. Okay, so there's my first part, 2.56 seconds. Okay, so then if I want to figure out the distance in the horizontal, all I need to do is use my velocity equation. Velocity is equal to distance divided by time. So my velocity was 25 meters per second. So 25 meters per second. Okay. So velocity is equal to distance divided by time. So 25 meters per second is equal to my distance in the x direction divided by the time spent in the air, which was 2.56 seconds. Okay, so go ahead and multiply both sides by 2.56. And we'll go ahead and do that on the calculator. 2.56 times 25 is equal to approximately 63.8 meters is equal to the distance in the